Okay. Lesson 4.9, number 41, states that a stone is dropped from the upper observation deck of the CN Tower 450 meters above the ground. And so we have a stone and it's going down. Okay. Now, part A asks us to find the distance of the stone above ground level at time t. So essentially we need a formula for position as a function of time. So we know S of 0, or position before he drops it, is 450. And so we also know that before he does anything, that velocity at time is equal to 0 is also equal to 0 meters per second. So, and due to gravity, we know that A of t is equal to negative 9.8 meters per second squared. Okay, so by using what we know about antiderivatives, we can use our acceleration formula to get a velocity formula. So we just have negative 9.8 is equal to A of t, so therefore V of t is equal to negative 9.8 t plus our arbitrary value c. And since V of 0 is equal to 0, c is equal to 0. And so our velocity as a function of time is just going to be negative 9.8 t. Okay. Then we need to figure out our position function. So if we go from velocity of time to position of time, we would get negative 9.8 over our coefficient 2, because that's our new exponent, and then times t, and then n plus 1, which is 2. And then we also have our arbitrary value d. And then we simplify that, goes to negative 4.9 t squared plus d. Okay, and then similarly, like we had in the last one, since S of 0 is equal to 450, we plug that in, our d is just going to be equal to 450. So that's our formula, negative 4.9 t plus 450. And that's our S of t. That's A. Okay. How much more? Alright, so now I'm going to erase this so we can do B. Okay. 41B. So 41B asks us how long it takes the stone to reach the ground. So when the stone hits the ground, S of t is equal to 0, because at the top of the building the height was 450 and at the bottom the height is 0. And so we can just plug that in to our equation. 0 is equal to negative 4.9 t squared plus 450. Simplify. 450 is equal to 4.9 t squared, and then square root of 450, that's 5, over 4.9 is equal to t. T is equal to 9.583 seconds. And that's B.
You started doing math.
Erase that now so we can do C. Okay. C asks us the velocity at velocity of the stone when it hits, right, like the instantaneous velocity when it hits the ground. So that would just mean that since the ball hits the ground at 9.583 seconds, we just need our velocity at 9.583 seconds. So we can just plug 9.583 into our velocity formula. So v of 9.583 is equal to negative 9.8 times 9.583, because it was just negative 9.8 t, and that comes out to negative 93.915 meters per second. So not too bad. And then D asks us to do the same thing as what we did in 41A, just now we sort of threw the stone off the building, so it has a velocity of 5 when it's dropped. Okay, so S of 0 is still equal to 450, but now instead of v of 0 being 0, v of 0 is equal to 5. Okay, so our A of t doesn't change. It's still 9.8, negative 9.8. And so, but instead of it just being negative, instead of our v of t is negative 9.8 t plus c, but our c isn't 0 anymore. Our c would now be 5, because v of 0 is 5 instead of 0. And so now we have to use the velocity formula to get to our position formula. So S of t is still negative 4.9 t squared, like we figured out in the last one, minus 5t, because c is equal to 5, and then plus our arbitrary value d. And since S of 0 is 450, d would be equal to 450, so plus 450. Okay, so now we need to find out the time at which the ball hits the ground. So when the time when position is 0. So S of 0 is equal to negative 4.9 t squared. Sorry, just 0 is equal to 4.9 t squared minus 5t plus 450. And so we do all the quadratic formula stuff. If I can scroll down. I'm just going to erase this. So 0 is equal to negative 4.9 t squared minus 5t plus 450. So quadratic formula t is equal to 5 plus or minus 25 minus 4 minus 4.9 times 450 all over 2 times negative 4.9, and then that comes out to 5 plus or minus square root of 8,845 all over negative 9.8. And so time can't be negative, so we can only do 5 plus So we have to cross out the minus. And so multiply that out, t is equal to 9.087 seconds. And that's it for number 41 after 10 minutes and 20 seconds.